And we are going to be using roots in this. Okay, and it looks like some of you do remember what that is. Yeah, Logan, what's the Pythagorean theorem?
A squared plus b squared equals c squared.
Okay, good. So a squared plus b squared equals c squared. And sometimes you might see it c squared equals a squared plus b squared. I just want you to know that that is the same thing. Okay, so that is what we're going to write underneath here and where that comes from. Okay, so or c squared equals a squared plus b squared. So if you knew that, you could fill in the first few blanks. So the Pythagorean theorem states that in a right triangle, the sum, and if we have a sum, Baron, what is a sum?
When you add up two measures.
Okay, when the result when you add two things together, right? Okay, so the sum is what you get when you do addition. And it's the sum of the squares. So see how you have the squares here? And it says of the lengths of the legs. And that's going to equal the square of the length of the what?
Hypotenuse.
Hypotenuse. Great. All right, so the Pythagorean theorem can only be used in this type of triangle. What is it?
Right.
A right triangle. Great. I'm going to use my cool stencil to draw my right triangle. Okay, so I want you guys to draw a right triangle too. Okay, so again, it has to be for a right triangle. Right? Now, it says the sum of the squares of the length of the legs. So your legs are going to be your A and your B. And it doesn't matter which one is A and which one is B. But A represents a leg and B represents a leg. The one that stands by itself is the square of the hypotenuse. Okay? Now, if you don't have numbers for all three of them, which a lot of times you won't because you're going to be solving, Ethan, how do I know which one is the hypotenuse without a doubt? So what if you don't have the links? So because you might have a side missing. Yes, okay, so the hypotenuse is always across from the right angle. Okay, so your hypotenuse is always the side across from the right angle. And I want you to think about why that makes sense based on what we've been doing the past 2 days. So the past couple of days we've been talking about if a side is longer, what do we know about the angle across from it?
It's the largest.
It's the largest angle. Why does 90 degrees, raise your hand if you can tell me. I want you to think about this for a minute. Why does 90 degrees have to be the largest angle? Yeah, Ella.
Because it's half of 180, so the other two have to be smaller than it. Because there are like two of them.
Okay, so Kaylin, add to that. Tell me what you're going to say.
So, like she said, it has to equal 180. And
Yeah.
90 plus 90 is 180, which means the other two angles have to be 45 degrees.
Okay, and they don't have to be 45. They could, but the other angles have to be less than 90 because What would happen if you had another one that was 90?
You have to
It wouldn't be a triangle. Yeah, it wouldn't be a triangle anymore, right? Okay. Good. Nice job. So, for our first example, we're going to give our answers in what is called simplest radical form. Now, this is something that we did on the Are You Ready packet, and it's also something that you guys had in your algebra review packet, but I'm going to go over that again with you. Okay, so for A and B, we're going to be finding the value of x. And we're going to draw our triangles. Okay, so remember they are right triangles. Okay, so here's my first one. This is 6, this is 2, this is x. Okay, so the first thing you want to do is identify the hypotenuse. Okay, so Sarah, which one of these sides, the 6, 2, or x, is my hypotenuse?
The x.
Good. And how do you know that?
Because it's across from the right angle.
Perfect. So if this is my hypotenuse, that means 2 is a leg and 6 is a leg. Now, again, it doesn't matter which one is A and which one is B. But if I set this up according to my equation, I would have 2 squared plus 6 squared equals x squared. Okay, so 2 squared is going to be what? 4. 6 squared? 36. So when I add those together, what do I get? 40. Okay, so if I have x squared equals 40, Ella, what do I do to both sides to solve?
You take the square root.
Good. So when I take my square root of both sides, and I just switch the sides just because we like to have x on both of them. Now, usually when you take the square root, what do you always put in front?
2.
You'll always put the plus or minus. Okay, but how do I know this has to be positive? It's a length, right? You can't have a negative side length. Okay, so even though it is plus or minus, you're always going to be choosing the plus. Now, it says write this in simplest radical form. So you're not going to be using your calculator to do decimals. Do you guys remember what we look for in simplest radical form?
Perfect square.
Yeah, Xavier?
Don't you just like add up what goes, so you do like the square root of 10 and the square root of 4 plus each other?
You are going to break it down. Do you know why you do 10 and 4 instead of like 8 and 5?
Because 4 is in a perfect square.
So what you're looking for inside the radical is perfect squares. Okay. So you're going to take the square root. I'm just writing the steps down so when you look back you can see it. Okay, so it'll be positive. And then you're going to look for perfect squares. Under the radical. Okay, now when I say perfect squares, let's generate a short list. Okay, and let's put it on the side here. So perfect squares. Okay, now the first perfect square is 1, well really 0, because 0 squared is 0, 1 squared is 1. But the first one that you have to check for is what?
4.
4. Okay, and what would be the next one? 9. The next one?
16.
Okay. All right. So we are